stereoscopic 360 movies, and they needed someone to develop an application for them. I did it in my free time while I was on exchange study in Japan. These months I've been working for Purple Pill VR to make their app, and they were so happy with it that they offered me a full-time job, which is nice. Especially now I'm just 22 years old and I'm already here talking about it. What I do is bringing the 360 movie content to all the virtual reality devices. But of course, this is coding conference, so I would like to ask you, who of you has already made something for virtual reality? There's not a lot of people yet. Who has a virtual reality device? Google Cardboard counts. Okay, that's great. So you know what it is, you have experience with it. Who doesn't know what virtual reality is? Great, then we'll skip that part. Well, for me, I create the applications in a program called Unity. Who has experience with Unity? I think a lot more people. Oh, okay. I think it's the perfect program to create virtual reality applications, especially because it's so multi-platform targeted. So at Purple Pill VR, we make our own 360 movie productions. We do that with a special 3D printed camera of our own. This is our camera. It has 16 GoPros, and there's on every side there's a left eye and a right eye. And these are about human eye distance apart from each other, and every left camera gets stitched into a video, every right camera gets stitched into another video, one for your left eye, one for your right eye, thus creating the stereoscopic 3D effect. We've been using this camera at multiple locations. We filmed at Sail Amsterdam, Gay Pride. We did several music videos. I'm now working on a music video for Kyla Lagrange and the Staat, which are not shot by us, but that's a client of ours that want to use our application. Then, momentarily, it is a very lengthy and difficult process to get all these little GoPro cameras, which are very high quality, together in one video. The technique to do this is called video stitching. This is, I think, Autopano. There's also a program called Nuke. What that program does is it puts all the GoPro videos together to create an rectangular video, an rectangular. Sorry for that. So what I do at Purple Pill VR is I'm working on this. This is what you'll see on our website, and it's a platform for 360 movie enthusiasts or hobbyists to easily create their own app without any knowledge of programming. So they send us their videos, they choose a style, they choose a color, and with just a few clicks, I can create an application for them. So that goes really quickly for them. For me, I have to make sure everything works on every platform. So, for example, this is an application of us which features one video of Kyla Lagrange. It's just simple. You show a thumbnail, and you can watch the video in 3D. Now, I have a video demonstration of our application. I hope the volume is not too loud. This is the current basic version we're working on. This is the Gear/HTC5/Oculus Rift version. And it's a basic VR interface. We have multiple videos. In this case, 6 videos, so they get resized a little bit, so you have the nice, they take up all the space. what this application does, it connects with a server, our own server, where all the videos are stored. So firstly, at first startup, it downloads only the images, it downloads all the paths, all the information it needs, and then the player of the user can download and then play the videos. Yeah, so the video gets deleted. It's a simple interface with a crosshair, and it uses multiple inputs to select something. So you can touch the screen, you can press the A button on an Xbox controller, any key on your keyboard, the Oculus remote, or the HTC Vive controller. Well, video gets downloaded, and it plays. This person does not hurry up. Yeah, now it will play. So when you press the play button, it will jump instantly into the video. This is one we shot ourselves for the Dutch soccer football club PSV. And this is with our stereo 3D camera. So what we see here is a monoscopic view. But of course, while you're watching this in a helmet, everything will be 3D and everything will come close to you. Okay. A simple VR interface which uses gazing and touch. So you can pause the video and watch around in a 3D paused frame, which is pretty cool to do. Now, of course, restart using the progress bar. Okay. I will continue to the next slide. So, for example, this is the menu you just saw in the program Unity, which uses, you have the VR camera with a raycast coming out of it, and everything with interfaces in virtual reality is done with some sort of tracking or raycast. So the buttons have colliders, you can select one and use different methods of input. So on the technical side, the programming, which is what I do, our project has multiple classes, objects who look like this. We have a startup on the top left with multiple cameras for the Oculus Rift, which is the OVR camera rig, also for Gear VR. Cardboard, which works on Android and iOS, and a HTC Vive camera. The beautiful thing about the project is that you can select a platform, which is in the purple area, give it a name for the client, select platform, select an icon, and you can build the app. And the application knows, okay, I'm on this platform, this is what camera I need to use, and this is what video player I need to use. So for the video player itself, we have a right and a left eye camera, and a Windows and mobile video player, because we use two different video plugins to play our video. And there's also a universal controller, which has some static booleans, like button is pressed, pressing the back button, and the input is different on every platform. So, for example, a simple click can be a touch, or the A button, or the keyboard, etc. So working on multiple platforms gives a lot of limitations. It's nice to have an Oculus Rift and an HTC Vive. You can make anything work almost on there because you have a powerful computer to use it. We assume everyone that has an Oculus Rift or an HTC Vive uses the minimum specs requirements, which we have at work, so it's easy to test out. On mobile, on the other hand, for example, Android has older devices, newer devices. Not everything plays 4K. Not everything can have the H.265 codec. And iOS, for me, iOS is terrible with video playback, especially in Unity. Let's see, because I think I'm going to... And something else you have to think about is the smooth experience. Your app will instantly get rejected from the Oculus Store or the Gear VR Store if there's any moment where the application lags or has frame drops. So, for example, this is the frames per second counter, and you see I'm loading a bunch of stuff, loading the images at the startup. There will be a massive frame drop, which Unity loves to do. So what I like to do when I'm loading stuff is a quick fade to black, and then load everything so the user does not notice the frame drop. You can also work with threading and make sure the application doesn't lag. Luckily, the Oculus software, so Oculus and Gear VR, has a built-in async time warp, which is pretty awesome. That the movement of the screen of your head goes on a different thread than the actual game application which is rendered. So for our application, what happens when the app starts up? It needs to download all the data. What we use is JSONs. JSON files are really, really awesome to work with, especially when we have to download data with like low file size. In here, on the left, we have our master JSON, which has the name of the application. You can select the theme, all the colors, and this is what the clients can fill out on our website. This is what I want it to look like. It creates a file like this, and it sends it towards the app at startup almost instantly. Also, all the videos which the app has are listed. So for example, I have one video here called Monique. I say this is version number 1. It is published. It will look in the folder Monique for this file, which is the video JSON. And that also has a title, description, what it shows in the menu. There's a mute option for if you want to use different audio as an overlay. We can say if the video is stereo or monoscopic. And for example, here we have a subtitle file that also gets sent with it. The beautiful thing about using JSONs is that in the programming side, you can convert it very easily to a class that can be used perfectly in the application. So this is the same as this one. We have an info, video, and data block that gets converted to this info, video, and data blocks, which are defined over here with all the strings and ints needed for the application. The videos that we'll use look like this. This is an equi-rectangular video picture in this case, which is generated by a 360 camera rig, which captures the complete world around you. And if you are familiar with for example, the texture that gets put onto a sphere, this will perfectly fit around that sphere. And if you look, when you're on the inside of it, it will look perfectly normal on every side. So we use stereoscopic 3D. So we have two cameras on either side, which generates a left equi-rectangular video and a right one. And the video is actually like this, like the side-by-side 3D movies which you can download for 3D TVs. And for that, we use the H.265 encoding software, which is pretty new and pretty awesome. For example, a 4K video, which we use 4K because the video gets stretched all around you. For example, for 5-minute 4K video would take up 1 gigabyte in the past, and now it's almost half that size. Very efficient video codec to use. And almost most mobile devices can play it. Funny thing, almost all Android devices play it, but for example, my laptop, which is, I assume, faster than that, cannot play this video on 4K. Now, how do you show this to the user? How do we, in our application in Unity, show the video to the user? We do that with a sphere that we generate. There's a very detailed video sphere. If you use a low-resolution sphere, then, for example, with high-contrast videos, you will start seeing the lines. We used to have a model which was around 10 MB, a lot of vertex data. And thanks to this, for example, this little piece of code, we've brought it down to 2 kilobytes, which is generated instantly when you start up the app, put it in the memory, and it is used for the backgrounds and for the videos itself. So in the video player, you'll eventually, this is the video I just showed you, you get 2 video spheres, one for your left eye, one for your right eye. And to do this, you just use a shader to put the video on the sphere and use tiling in the case of stereoscopic videos to pick only the upper half or the lower half of the video and put it on the sphere. Press play on your video plugin and let the player look around from the inside. The cool thing is when you use material mapping, which is what this is called, you can also do, because you use a shader, you can also do some tricks. So for example, we have a little funny filters you can use for that. So normally, the normal shader would be half C is the texture, and then put it in O.albedo. But if you do an extra line of code, you can create a grayscale filter, negative filter, black and white filter, or for example, a posterized filter. And it's really cool to watch these videos when they're all negative in 3D. Well, this isn't very useful, of course. It's just fun to do. But we also made some sharpening filters, which work really well in dark videos, especially on 4K. 2K, it doesn't really work that well, which increases the experience. To do this properly, if you put both the players in the middle, you want to put the video spheres on the same location around the player, it will look a little bit like this. Two spheres through each other with 2 different textures, you get a hell of a Z-fighting. So that's why all the cameras from Cardboard, Oculus Rift, HTC Vive, they all work the same. They get an input from the device, and they have two eyes that they show on the screen, which are cameras. And cameras can have layer masks, and giving both spheres a different layer, and using layer mask, you can actually decide what every camera sees. So you can show something in your left eye and something else in the player's right eye. If you toy around this a lot, you will get a lot of headaches. And then, for example, the menu interface that we use, when this is brought up by the user, the stereoscopic 3D effect will actually disable, because there can be a moment where the video is paused and someone reaches with their arm forward towards you. And if you bring up the menu, which is at a nice 2-meter distance from your eyes, because everything works in distances, meters. There is no such thing as a 2D interface in virtual reality, because it needs to have depth. So the most comfortable place to put your interface is at around 2 meters from your eyes, not turn your neck too much. And if the video is paused when someone reaches out to you, gets really intimate in the video, then the whole stereoscopic effect will be distorted, because the menu will become an overlay of that, which will be in the distance, which creates massive headaches. That's why we have chosen to disable the stereoscopic effect when an interface is shown. And there's a big problem we have with that, because our application also supports subtitles, but only in 2D video. We're trying out with subtitles now. The problem is subtitles need to also have a depth to show them, but what we do is the subtitles float in front of your field of view. When something gets close and you look the wrong way and the subtitle goes through it, it will break the experience. So I was also curious if any of you has maybe thought about this, and maybe some solutions, which I'm still looking for, to make this work. Something else that we use is a very special microphone, which we put on top of our camera, which is a directional microphone that for ambisonic audio, which is instead of stereo, where you have a left and right ear, you have 4 audio channels, which generate a different, will be played at a different volume depending on where you're looking. This is a simple setup from Wikipedia, how it works. We actually use a plugin now for this because it has higher quality, and we can stream it instead of load the MP3 before the video starts. But you can actually make this yourself. If you have an ambisonic audio, you have four audio tracks, which are, I think, 2 MP3 files. You can try to make this yourself. By looking at this diagram, depending on what direction your ear is, you will hear different volumes of the audio sources, which can also be above you and below you, which is really amazing for virtual reality experiences. Hearing something and you can actually hear how far it is behind you. Something else we have been working on is hotspots. This is a nice hotspot icon that we use in our videos. They will fill up like this with the help of an RGBA map. That's what I like to call it, instead of an alpha map. And what this hotspot will do when you look at it will bring you to another video in the project at a certain time. So what this allows us to do is create an interactive 3D virtual reality movie with branching storylines. So we now have the technology to make seamless transitions between videos, to make every user's experience unique. And we're actually right now working on our first very own interactive movie production. It's being made by 2 colleagues of mine up top, Joris and down below, Jelle. And we're right now building a set in the studio next to our office to create a 3D movie, interactive 3D movie experience, which is something I'm very looking forward to. Let's see. I'm going rather quickly. Let's see. I'm going quickly to this one. Something else I've been really looking forward to is Manosphere. You might have heard of it, seen it somewhere. And this actually, instead of the HTC Vive, which uses remotes, lets you actually use your hands, see your hands in virtual reality. And we can't wait to get our hands on this and also implement this in our software. Some other things we're doing is combining real-time 3D scan from Kinect and trying to make a real-time 3D video, which you can actually walk through with the HTC Vive. Looks amazing from the front, not so much from the side and the back, but it's still a nice experience. And we're also combining the HTC Vive and Oculus Rift to use them together on one computer. We couldn't get 2 Oculus Rifts to work on one computer, but we could have both services running in the same application. So it's really cool to see someone who is also wearing a helmet, see them through like a 3D application filter and see their head move, and you can also use the HTC Vive controllers with the Oculus Rift. I hope I didn't skip anything. So this talk was to hopefully get you guys motivated to try out VR, to at least try Google Cardboard if you haven't done it, maybe buy or borrow a VR device and try make stuff for it, program for it, because it's an amazing new experience, a new medium to bring entertainment, but also, for example, applied for healthcare, training, educational purposes. It's a new medium that needs to be explored more, and like you saw, not a lot of people have worked with it yet, and I hope that you all be more motivated to do so. Thank you very much. This was my talk, and I hope there are questions, of course. Are there any questions? Yeah.
What would be good enough?
It depends. Everyone with a smartphone can buy, of course, Google Cardboard. The best glasses that are out there are right now the Oculus Rift and the HTC Vive. It depends on if you have the room for it. I highly recommend the HTC Vive, which it is amazing to walk around in a 3D space. They are a little bit pricey though. They're still high price, and the content there's not enough. There's not as much content as, for example, PlayStation or an Xbox, but that will hopefully change rather quickly. Yeah. Yeah.
What is the plugin's name?
The plugin's name is TB Audio. Yeah. That doesn't. You mean instead of not you don't you mean 360?
Yeah, 360.
Yeah. They're actually, which is not something I've researched so much, but it is very important to keep the action where the attention is present. So in our videos, we sometimes use light, or we build a set in a certain way that it all points to a certain point where all the action happens. And it is true that most videos, I think almost all of them, everything happens in front of you, in the middle of the video, and the back is there because it just can be there. But hopefully with the use of interactive videos, we really want to get the people out of the chair, look around, and see what else is to explore. And I think interactive movies will definitely help with that. Yeah? I've been looking to that, yeah. The problem is that the videos are on big spheres which are all the way in the distance. And if we're using 3D video and we want to, for example, make a cube, something basic, float around towards that space, it will always be on top of everything there. So there are multiple ways you can do this. You can try do the Kinect real-time scan approach by using a depth map, for example, and then clip the object when it's further away than a certain value. But so far, what we're doing right now is just text floating around or an interface or something. Yeah, so it is very interesting, but really hard to do, and I haven't seen it be done. I haven't seen it being executed well yet. Yeah.
360 video is always looking around, etc. But it's not
Yeah.
walking around.
No.
Is there any capabilities as such? Are you really then looking for?
Well, there is going to be a light field camera pretty soon, which is like a machine this big, and it will capture instead of like a normal camera, it will capture light, and then every light point has a depth with it. But you still have the like everything looks great if I stand in the middle. If I walk towards something, this will look nice, this will look nice, but you'll see a shift, and there is no data behind that. There needs to be techniques to do this, or use multiple cameras to do this, but that needs to be something in, for example, a game engine or something strong, because you can't just put it in a video. What is possible, though, is we're using Nuke to stitch our videos together. And Nuke is an amazing program. What it does, it looks at the overlay between the cameras, and it calculates a depth with it. So we can actually export a depth render of the video, which we put in the alpha channel of the MP4 video, which I can use to eventually make a little parallax effect. But it will only work with a few centimeters, because when you walk around, you can walk around in the video, but everything will be distorted, because everything is recorded from one point, and if that point can't see something, then you can see it if you walk there. But for the 3D effect, a little parallax shift would be amazing. And yeah, I'm still I'm trying to do that, but they're also trying to do that at Google, and still haven't done it there. It's something really cool, and I hope it will be done soon. Anyone else? No, then I guess I'll finish it up. Thank you so much for listening to me, and I hope you all be a little bit more motivated to work with virtual reality.